today's tutorial, we're going to be adding some foam to our water shader. Foam in water happens where the water collides really quickly with itself or with other objects. So there's a lot of different places we could place foam. In our particular example, we have some really calm water in this area. And so adding foam may not be super realistic, but we're going to do it anyway just so you can see how it's done. And then you can choose how you would like to add it in your particular water applications. The first thing that I want to do is show you the textures that we're going to be using in this shader, and I'm including them in the description if you'd like to go ahead and download the original TGA files that I'm using. The first texture that I'm going to show you is our foam texture. And there's something really interesting happening with this texture that I want to make sure that I help you understand. This texture has 3 channels, red, green, and blue. And the red channel looks like this. It's just some really sparse foam. The green channel looks like this. It's kind of like a medium thickness of foam. And then the blue channel looks like this, which is basically full thick foam. And what we have here is basically 3 different amounts of foam. And what this allows us to do is make the foam thick in some areas and thin in other areas by having 3 different densities of foam, and we pack those into a single texture with a red, green, and blue, meaning thin, medium, and thick foam. The reason that we need 3 different foam masks is that foam is not something that you can evenly blend out. I can't just take the full thick mask and make it darker, or in other words, make it more gray, more towards black, because foam doesn't work that way. It's dense or more thin instead of just like ramping up with a gradient. So we have to have 3 different masks, one for thin, one for medium, and one for thick. The other texture that I'm going to show you is a gradient, and this is the gradient that we're going to use to control which of those masks to show. There are 3 channels in this texture as well. There's the red channel. This controls where the foam is going to show up when it's thin. So over here on the left side, you can see that it starts out black, but really quickly it ramps up to white. And that means that the thin foam layer is going to show up for the majority of the time. It only won't show up when we give it a value of 0 or black. All right, our second channel is green, and it looks like this. And you can see that it's mostly black over here on the left, and then it ramps up with kind of a medium velocity and then stays. And then our third channel, blue, you can see that it's black almost the whole way and then ramps up just a bit here at the end. And this controls our thick foam. So our thin foam is active almost for the entire gradient. Our medium foam is active for about half of the gradient. And then our thick foam is active just at the very top end. So we can sample this texture, this gradient, with a value that controls how much foam to apply. And the thin foam will kick in at the beginning, the medium foam will kick in the middle, and then our thick foam will only contribute at the end. So the value that we use, the texture coordinate on the U that we use to sample this gradient, will be kind of like our overall control of how much foam we're going to apply. Okay, so these are our 2 textures we're going to be using today. And I'll just go ahead and turn these channels all back on so that you can see what they look like all together. And let's jump right into our shader and start adding what we need to create the foam. The first thing that I need is a texture object. And then the next thing that we need is a texture sampler. And we're going to add our gradient to this texture. Alright, so how are we going to do the movement of the foam? Well, to do the movement, we're going to use a node that's built into Unreal that's called Motion Four-Way Chaos. This is a function that comes with the engine. So I'm going to add a function here, a material function call, and then I'm going to come over here to the material function and drop down where it says none, and I'm going to type four-way, and you can see I get this result called Motion Four-Way Chaos. And I want to take a minute to explain what this node does. So I'm going to double click it just to open up this function, and we can jump in and take a look at the network. So you can see here that it has an input for a texture object, which we're going to be giving it in a minute. And it samples that texture 4 times. And the UVs for each of these texture samples are adjusted with these 4 panners. And what this is doing is it's sampling the texture 4 times, where each sample is panning in one of the 4 different compass directions. And so you have 4 different copies of this texture all panning across each other in different directions. And what that does is it creates some motion chaos. This is why it's called Motion Four-Way Chaos, because it's creating this scrolling pattern that's really hard to pick apart in your mind exactly what it's doing. And that's the kind of movement we want for foam, because foam in water is really chaotic. It's moving in all these different directions. And in reality, if you take a look at real foam, the movement is much more complex than what we're going to do. It does all kinds of undulating and drifting and flowing. But to keep things a little bit less expensive, we're going to be using this Motion Four-Way Chaos node. Alright, so let's jump back to our shader. We've got Motion Four-Way Chaos here, and we're going to plug our foam mask into that. And now we need to add a couple of more controls here. For speed, we're just going to give it a constant value of 1. And for our divisor, we're going to give it a constant value of 0.25. Divisor is a little bit of a confusing term. If we go back here and take a look at our function again, what you can see is these 4 texture samples are all added together, and then they're multiplied by this divisor. So if we have 4 samples and we add the results, that gives us a maximum value of 4, if all the samples are white, for example. If we then multiply by 0.25, it'll give us an average of all of our 4 texture samples. So we're going to do that. We're going to multiply by 0.25 for the divisor. If I were to increase this value, it'd give me brighter foam, and if I were to decrease this value, it would give me dimmer, less bright foam. Alright, the last thing that we need is UV coordinates, and we're going to use world position for that. And then we just need the red and green of the world position, so we need to create a component mask. Now in order to control the size of our foam, I'm going to multiply by a constant value, and in this case I'm going to use a constant value of 0.07. Actually 0.007 to give me the correct scale for our foam. And then I'm going to plug that right into our texture coordinates. So I'm projecting this from the top down in world space. Okay, let's take a look at our results. So I'm just going to take the results coming out of our four-way chaos and plug it directly into the color of our water, just so that we can see temporarily what our results are. And this is going to look a little bit crazy because our color used to be a nice blue watercolor, but now we're replacing it with the color that represents these 3 channels. So yeah, you can see, this is pretty weird looking, but you can see what our four-way motion chaos node is doing here. It's basically scrolling the foam across itself. And the different colors of foam here, you can see there's like red and green and blue all mixed together. those are the three different layers or thicknesses of foam. And we actually need to split those out. So let's go ahead and do that now. I'm just going to add in a split components node so that we can expose the red, green, and blue channels. And I'm just going to go ahead and add them together. So I'll add the red to the green, and then I'll add the result of that to the blue. And so now, instead of using RGB as color, we're using R, G, and B as individual channels. And let's take a look at what kind of a result that gives us. Alright, so now we have a foam that looks a little bit more, well, it's extremely foamy right now. But at least it looks a little bit more like foam because it's white instead of using those individual mask channels for color. We're using them as masks. Alright, so now that we've got this going, we need a way of controlling where the foam is going to appear. And part of that is using the gradient. So let's go ahead and hook up this mask gradient that I talked about before. So I'm going to take the result of the four-way motion chaos and we're going to multiply it with our gradient. And so here's the result of the gradient multiplied by four-way motion chaos. Now you remember each of the channels of the gradient represents the different foams. So the red channel, the gradient was white almost the whole length of the gradient. The green channel was white for about half the gradient, and then the blue channel was white just at the very edge of the gradient. And that's how we want to control our foam. We want to add the thin foam for most of the range, the medium foam for about half the range, and then we just want the really thick foam to kick in right at the top end of the range. Oh, and there's one more thing I need to do. I need to add a saturate here. Since we're adding these channels together, there's a possibility that our results will go above 1. So in order to clamp it between 0 and 1, I'm going to add that saturate node there. Alright, now with this gradient, I've given myself a really nice way to control where the foam is applied. If I take a look at water, foam is going to happen wherever the water is slamming up against something, or where it's churning on itself, or where it's flowing really fast. So the value that I pass into my gradient here as my UVs is going to determine where that foam gets applied. And I'm going to let you decide how you want to handle that. I'm going to show you one method and talk about some others that you could use, but mostly I'm going to leave this up to you to decide where you want to put the foam. There is one really important thing that I forgot to mention, and I'll switch back over to my gradient here and show you what I mean. I want my gradient to go from 0 to 1, but I want it to stay, if I give it a value higher than 1, I want it to clamp. So it's really important to change this x-axis tiling method to clamp, and also the y-axis tiling method to clamp. That ensures that my gradient doesn't repeat itself. That's a pretty important setting to have. Okay, in order to control where the foam goes, just for now, what I'm going to do is use depth. And so down here in my shader, I have my depth calculation, and here's the value that I use to determine how much depth fog to apply. In addition to using my depth calculation for depth fog, I'm also going to use it to control where the foam happens. So where the water is shallow, or in other words, right up against the rocks, that's where I'm going to be applying the foam. Okay, so I'm going to take this value here, where I have this 1 minus, and instead of dividing it by 100, this is like a maximum depth of a meter, I'm just going to divide it by 20, meaning the foam will be to a maximum depth of 20 centimeters. So I'm going to add a divide, and then I'm going to add a constant value of 20, and I can increase or decrease this to add more or less foam depending on depth. I'm going to saturate that value and add a 1 minus node because I'm going from 0 to 1 instead of 1 to 0 here with my texture coordinates. Alright, let's connect this to my UVs for my texture sample, and we'll save it and take a look at the result. Alright, so let's back up a little bit. You can see that I'm just using the foam as my color right now, so my water color has gone away. But what we can see as a result here is that we're applying the foam just in the areas where the water is shallow, or where it's bumping up against the rocks on the surface. So that's one way to apply depth. This method is pretty cool, but like I said, you'll probably want to use 1 or 2 additional methods to determine where foam is. So if you were to paint a mask, you could project your mask in world space, and that mask could determine where your foam goes. So you could add that value here, and then you could have a top-down mask where you painted exactly where your foam was going to show up. You might also do some math with your Gerstner waves and determine, where the foam or where the waves have their peaks, and put foam in those locations as well. So like I said, we're only using depth to add foam right now, but there are lots of different ways that you can add foam, and all of them can be added together and combined to create this U value for our gradient. Whatever methods you choose, you can use that for the U value of the foam gradient here, and it'll apply foam where you've told it to. Alright, so let's come down here again, and we're going to add the foam to the color that we already have. So this is our nice depth gradient with our blue color values, and I'm just going to add the whiteness of our foam to that for color. And we also want to make sure that our foam is opaque. And so I'm going to add another add node here and come down to our opacity value, and we're going to add our foam to our opacity so that the foam is opaque. Oh, you know what? Actually, I want to add our foam before the edge fade. So this depth fade node here is doing an edge fade, and so I'm going to take the result of this and add our foam opacity to that, and then multiply our edge fade so that we still have it. If I were to add the foam after this multiply here, the foam would run right into the shoreline and get rid of the results of this depth fade, and we want to make sure we avoid that. Alright, let's save this and take a look at our final result. Alright, so we've got our foam, and it's now combined with our really nice blue color, and we've also combined it with our opacity so that the foam is opaque on the surface. And this is pretty cool looking. Like I said, you can add additional ways. If you have steeper waves, you could calculate where the peaks of the waves are and add foam there. Or you could create your own world space projection mask and paint where the foam went. Lots of different ways of doing foam, and we're just using depth today. Let's go back to our shader and do a quick review, and then we'll wrap up. So we have our foam texture with its 3 different layers. We're passing that into our 4-way motion chaos, sampling that texture 4 times and scrolling it in all 4 directions, projecting in world space. We're using depth to determine the U coordinate for our gradient here, and then we're multiplying this gradient with our 4 texture samples to determine the thickness of the foam, whether it's sparse foam or medium foam or really dense thick foam. Then we're splitting up our 3 different layers and adding them together as masks, saturating the result, and then adding that to our color and to our opacity. And that gives us the final results of the foam we're looking for. I hope you enjoyed today's tutorial. If you did, hit the like button and subscribe to my channel. We'll have some new tutorials coming up real soon, hopefully a week from today. Have a great day, everybody. We'll see you next time.